So my name's Tim Miller. I head up the ServerTemplates and images group in engineering for RightScale. Kerry Penniman, who's going to be taking the second half of this, is the technical lead for Linux server templates and images. So any questions you have on Linux server templates and images, definitely seek him out. Although with the latest Windows Azure, he was the guy who built a Linux image that ran on Windows Azure last week. So here's our agenda overview. I'll take some overview. We'll talk about what templates are multi-cloud right now. Then Kerry will go into a deeper dive, get into actually some code, and then we just have a page of references we probably won't go through, but then we will leave a lot of time for Q&A. Last time at the last conference, Kerry and I spoke, and we finished early, and we had a lot of great questions. So let's have a good Q&A session on any topic, related to server templates and images. We're happy to answer those. So why multi-cloud? I almost thought I could skip this slide after the morning session. So if you were around for the morning sessions, all three of the customers really hit on some of these reasons of why they're thinking about multi-cloud, why some of them already have gone to multi-cloud. And so here's just a couple of examples. This isn't an exhaustive list, but performance, not only is it performance of the cloud, responding to you, but there's performance in how fast a VM is provisioned. It's different between the clouds. How's their storage? These may be a concern to you, and if they are, then you take that into account. Of course, disaster recovery, moving into a different cloud. We all know clouds go down. A lot of these are self-explanatory. Price, obviously pretty easy. Compliance, a lot of compliance stuff starting to pop up as the governments start to figure out how they want to regulate this, what it means to them, the whole data issues, in-country data issues. Certainly SLAs, feature sets, all these things are taken into consideration as why you might want to move off of working with a single cloud and going multi-cloud. And then obviously one of RightScale's great use cases, the ability to move between a private cloud and a public cloud. So I put this slide together. This is like, put it into practice. So how would you think about this? And if you're going back to the other slide and the requirements filters here, you're going to, as soon as you start to optimize clouds or thinking about going to multi-cloud, you have a couple of options. You can say, hey, we're a one app company. We're just going to move it into multiple clouds. And we're going to use some requirements filters to figure out which other cloud to go to. Or if you're a larger company, you have multiple apps, then you may start looking at doing it by app. And again, you come through the requirements filter, and I just have a few of them listed here. But you'll come through the requirements filter and say, oh, I'm strictly worried about cost with this one. So I go down in the resource pools, and I figure out what's the cheapest cloud I can run in based upon my requirements, and that may be your decision. Other apps, maybe same company, you may be more secure conscious. Maybe it's something that's you need a much higher level of security. You still come through the requirements filter, and it may take you to a different cloud. And so that's where for companies who, and everybody's on a different part of their journey to the cloud. So and I'm sure everyone is in a different spot in this room. But as you go from one cloud and start to go into multi-cloud, you use these requirement filters that are business cases, business reasons for your particular company to decide what to do, where these resource pools are. And as you optimize then, you'll get from going to multi-cloud to optimizing, and you start to optimize your costs, performance, and any of these number of feature sets is what you'll start to look for as you move out into different cloud resource pools. So here's the current set of supported RightScale multi-cloud templates. We have Linux templates and Windows templates. The list over here on the side is the ones that we put out. And really these are used by customers in two different ways. One is you can use all these templates together in a deployment and fine, right out of the box, stick your app on top. The database managers are fully enabled to do HA, and there's a lot of features we're not going to go into because it's not about a template talk today. But you can combine Windows, Linux images if you need to, and we offer this set. But the other way customers use this, and a lot of our customers go down this route, is they use these as reference architectures. You may not see your app up there, You may not see your database up there. And so they'll open up the templates, they'll see how we built them, they'll mimic them, and you'll create your own templates. There's a lot of benefit to that as well. You can streamline them to exactly the inputs you need, and we have lots of customers. And I think it's still, I'll keep going back to this, I still think it's a journey. Start with off the shelf, get cloud going, understand how it works for your company, and then work towards optimizing and growing. And as we're growing and adding new things, you'll just follow right along with us. I also listed, just pulled out some of the customers in the MultiCloud marketplace. That's where we store all these templates, all the images. These guys also do, a lot of our partners in the other room all do MultiCloud templates. Almost every partner we have is moving towards MultiCloud templates because as the other clouds, the other non-Amazon clouds start to build themselves up and deliver features that are very interesting to you, that drives their business as well. So they'll be moving. And then third, which is not on the slide, but make use of the RightScale services group. They have a lot of templates. They don't publish them, but if you don't see one and you say, oh, I need a JBoss template, they probably have already done one for a customer, and I'm sure they're happy to work with you. Some of them are already multi-clouded as well, or it's just another starting point, another reference architecture you can use. They, of course, build them with best practice as well, and you can take those in and use them. So I'm going to go down one more layer now and into some dashboards, some screenshots. This is a server template screen in the dashboard. This happens to be a base server template. You can see server templates are made up of boot scripts, operational scripts, and there's no decommission scripts in this one, but if there were, that's where they would be. But as the title says, the script is a script. And really, you're maybe thinking, so what? I have these scripts. Probably everyone in here has these scripts that do this type of thing sitting in some directory. And that's really not the point. We all have these scripts. What the framework or what RightScale does is put these together in a manageable way. But really, it's still, this isn't enough. This isn't enough to go to RightScale just to have a server template. It's a big thing. But what really starts to move into a real competitive advantage is when you start looking then at the images. So a multi-cloud image, sort of a misnomer. It's not one image. Multi-cloud image is really a collection of images. Right now, 50 Linux images and 58 Windows images that are when we call MCI, multi-cloud image. And what you can do, and this happens to be a Linux server template, but you can see those are the OSs that we support, CentOS, Rails, and Ubuntu. And then you can see right here, here's the clouds that these run on. So you have the server template and the scripts combined with the multi-cloud image, and that's where you get your power. That's where you get your power to move across clouds and with one set of scripts. And so what you end up with is code once, run anywhere. So this is really the launch screen. After you've picked your image that you want to run, I decided it is sort of noisy, CentOS, and then it'll ask you, well, where do you want to launch this cloud? I mean, this VM. And so you can pick it and off to the races. You can come back around and relaunch, same set of scripts in a different cloud if you wish. Could be your private cloud, could be a public cloud. So that's really where when we talk about multi-cloud, that's really where the power is. The power is in you write the scripts. They could be anything. They can be chef recipes. They can be Bash. They can be Perl. But what you have then is you connect them with the multi-cloud image, and that forms that unit and we abstract all that cloudness. I don't know if that's a word. I don't think cloudness is a word, but I just defined a new word. Yeah. We extract the cloud away from you. So we do all that heavy lifting. We provide the 50 images. You don't have to worry about all the different cloud nuances. We do that for you, and that's what makes really the multi-cloud server templates very powerful. So that's it for me. Kerry's going to come in and really now go into a deep dive on, and hopefully he won't lose too many of you. He's a great engineer, and he's going to talk about really what some of the features down below, really down in the code level, make multi-cloud templates very exciting.
Hi, my name's Kerry. How many of you have actually used a RightScale server template before? Can I see a show of hands? Okay, so you guys have seen the dashboard. So the rest of you, those screenshots that Tim just showed, it's probably your first view at what a server template is. And it's just a collection of scripts sitting on top of these base OS images that we've designed to run on all these different clouds that we support. So now I'm going to, like Tim says, dive a little bit deeper into some of the platform constructs that we have and some of the tools that we build into our server templates that kind of facilitate cross-cloud and cross-region operation of your servers. So I'm going to dig into a few features that are, really enable you to do cross-cloud orchestrations, and also touch on some features that are coming out in our new server templates, which are going to be released this month, end of the month, just that users have been asking about, and that we're pretty happy to be bringing to market. So with that, I'll start with my first feature, machine tags. And machine tags are a really simple concept, but basically it's a way to attach just some extra metadata to your running server. An example that we have here, let's see, there's a laser pointer on that, right there, is an example of a machine tag. And really it's saying that this is a load balancer tag, WW equals LB. We use that to mean that this is a load balancer balancing the www host. And we use these on our load balancer server templates. And here's some examples of more tags that actually get put on our app server. And we provide tools to add, remove, and query these tags. So from the scripts, from the boot scripts, that list that you saw Tim show you, these automatically get, one of the scripts just says, okay, tag myself with my IP address, my port, that I'm actually an app server serving for the www host, and that I'm now active and ready for connections. So okay, this is just kind of some static information that it puts on itself. Okay, so what can I do with that? One of the things is our other new feature, remote script invocation. And what this is one server can actually say, hey, I'm here guys, send a message to all these other servers in the deployment and have them run a script remotely on themselves. So an example of that, it's probably easiest to explain by an example. And here's one of the tools that we provide. This is just a command line utility called rs run write script. It's built into our write images. And what this does is it runs a write script with the name attach app server with the parameter recipients tag load balancer. This is our load balancer tag that we had before. So basically what this is saying, this would be run on an application server that is just booted up and he's ready to accept connections. He would run this and say, okay, all the load balancers in my deployment with this tag, have them run this script. And over the RightScale platform, we would then send, let's say you have 2, 3 load balancers, all of them will get this instruction, and all of them would start running the attach app server at the same time. This last parameter is a JSON file, which presumably has some information about the app server, like the IP address, the port it's listening on, maybe some kind of unique identifier. And that information would be used by the script to update the HA proxy config. So it would start load balancing this application server. This is pretty cool stuff, because not only now can you say, hey, I'm an app server, add me to your load balancing pool, load balancers, to which it's pretty easy to do as long as they're in the same network. But because we're using the RightScale kind of management backplane, these servers don't have to be in the same deployment. They can be in different regions of the same cloud. They can be in completely different clouds. As long as they're in the same deployment on the dashboard, we allow you to send messages back and forth to these servers to come up with some really cool orchestrations. And we use these within our 3-tiered stack for all kinds of things. And we'll get into a couple more of these. Something completely different on the other end of things is kind of our storage toolbox. So on the cloud, it's all about persistence. You have some kind of virtual compute source running somewhere that you need to get your data up to so you can work on it, you can crunch it, and then you need a way to back up your data in case that VM disappears. Because for those of you who are running on the cloud, you know that those can disappear at any moment. So you got to protect that data. And so our storage toolbox is kind of a base server template that we use. We actually put it under our database manager ServerTemplates for backing up and restoring database snapshots. So the two constructs in the storage toolbox is primary backup and secondary backup. And primary backup uses the local cloud storage available to the VM. So if there's volumes, we use volumes for snapshotting, like EBS volumes, Cloud Stack volumes. It's the fastest way to back things up that we found. So we use that when it's available. Now, not all clouds support volumes. So in that case, we will use some other like ephemeral drive or extra drive for putting an LVM on top of it, taking a snapshot of that, and then fragmenting that data into files and sending them up to a remote object store like S3 or Cloud Files or Swift, SoftLayer, so on and so forth. Secondary backup is for getting your data off of that local cloud. And I'll kind of go into that in the next slide, but it's basically a way of getting your data off of the local cloud just in case there's an outage. Your data is still available, because if you're just saving the EBS volumes, you know, that region goes out, you might not be able to access your data. So this overly complicated diagram is kind of depicting two of our kind of best practice deployments. And our server templates that Tim showed basically do this kind of configuration out of the box. You launch load balancers, app servers come up, say, hey guys, connect me to yourself. Database comes up, opens up firewall ports so the applications can talk to it. But what I want to highlight here is that, so you have Cloud X and Cloud Y. And Cloud X, you're running your main application, and it's using volumes for snapshots. So every couple hours, 4 hours daily, they'll be taking snapshots. Those snapshots go somewhere in that region typically. But you're taking these real fast snapshots. Your master database dies. You have a hot slave. You promote that slave to master. You're up and running, you know, with minimal downtime at all. If you lose both of them, you might be able to still launch, get a volume going. But if this whole cloud goes down, you're basically out of luck. You know, you got to wait for them to fix it, and that's not really acceptable. So one of the constructs that we have built in is the secondary backup. This dotted line here, where periodically you will say, you know, instead of a primary backup, hey slave, take a secondary backup to some other cloud storage. Get it off this local cloud in case it goes down so I can restore. And if that cloud goes down, you can use that secondary, you can do a secondary restore to our exact same server template, launched with a couple clicks of a button in a different cloud or a different region, and have that thing back up and running. This is also useful for priming a slave that you want to replicate across regions or clouds. Okay, the next thing I want to talk about is Chef support. So now we, in addition to write scripts, which we've had for the past 6 years, we now have native Chef support built into the dashboard. So these next server templates are going to be written completely in Chef, which has been a real joy to work with. We have a pretty big team of developers, and we're really excited about this configuration language. How many of you actually know what Chef is? How many of you have actually used Chef? Okay, cool, cool. So for those of you who don't know, Chef is a configuration language, or a DSL, domain-specific language, specifically for configuring servers. So while you can write your own scripts that do the exact same stuff, Chef gives you a lot of this stuff kind of for free. It has these high-level abstractions called resources that manage different parts of a server or system. Like there's a resource for a cron resource that manages your cron jobs. There's a directory resource that manages your directory. You know, you tell it what user you want that directory to be at, what group and what mode you want that directory to be set to. And it will, when you run the recipe, it'll make sure that that directory exists and is in the state that you prescribe. And these built-in components that you get for free when you use Chef, they're idempotent, How many people know what idempotent means? Yeah, I had never heard this word until I started playing around with Chef. But what it means basically is when you run it once, okay, that directory is now has the right owner, right group, right mode. You run it again, Chef won't do anything. It won't change a thing. It's just, if it needs to be changed, it will change it. And it has nice mechanisms for notifying services to restart. Hey, I touched a configuration file. You need to restart Apache, or you need to reload Apache. If I didn't change the configuration file, I'm not going to notify anybody. No services have to restart. Just keep going. Everything's fine. So there's some really cool stuff built into Chef, and we're really excited to be using it and offering it. Another godsend is the source control management is external. You can use SVN or GitHub, which really makes, this is traditional source control management. We have multiple developers, and each developer can have their own branch, be working in their own branch, get their server templates and scripts working in isolation, and then once they get everything working, they can merge it back to the master branch, and we work towards a release that way, and it's really brings sanity into managing a large set of server templates. They're easy to customize. Pull requests, we get people from the community submitting patches and improvements to our cookbooks currently. There's a large community out there that are already using Chef, already trained on Chef, and there's a lot of help for writing Chef. There's a really great mailing list on the Ops Code site. There's also an IRC channel for Chef, which has at least 100 people on it at any one moment that are all willing to help. It's a great community, and it's a great language to be playing around with. One thing to note if you're a beginner to Chef, there's the Chef language and there's a Chef platform. We natively support the Chef language. We don't natively support the Chef platform, but we work with the Chef platform. And with this latest release coming out, we'll be up at Chef 0.10. The last feature I want to talk about is firewall support. So not all clouds are created equal. Not all clouds have security groups like EC2 does. So we have to go with the lowest common denominator and protect these VMs that are launched from ServerTemplates. And so to do that, we've written a sys firewall recipe in Chef, or cookbook in Chef. So in Chef, there's recipes which are very analogous to write scripts. And the write scripts the recipes are organized in cookbooks. So you kind of see the culinary theme there. But so there's 3 recipes in this cookbook for managing your firewall on your VMs. And this we use IP tables for managing it. The default recipe will enable the firewall, install IP tables, make sure it's configured, that all ports are closed, except for by default we open up port 22, 80, and 443. And these 2 other recipes, setup rule and do list rules, they're kind of convenience operational scripts that you can use to open and close ports on a running server, or list ports that are open on a running server without having to SSH into the server. But really the meat of this cookbook is in what's called a lightweight resource called the Sys Firewall Resource. And this simple resource has 2 actions, update and update request. So update action, the update action is used to manipulate the ports on the running server, the current server that runs this statement. So this is an example of a piece of Chef recipe code. This is a Chef resource call in a Chef recipe. And it's best to be read backwards. So we're calling, on the Sys Firewall resource, we're calling the update action. We're going to enable the port, so open the port 3306 on all servers with the machine tag app server active true. So basically we're going to be opening up our 3306 port to all the application servers with this tag. And we use this on our database manager. So when our database manager comes up or slave comes up, we will we'll run this because all the ports are closed, nobody can connect to 3306. We have to say, okay, where are all the app servers in my deployment? I need to find them and grab their IP address and open up the port specifically to each one of their IP addresses. So if you have 3 app servers, the database will come up and find them, do a query on these tags using some of those tools that I talked about before, and open up that port. So, so the update request is the converse of the update. You're asking someone else to open their port to you, as you being the server. And reading this one from bottom up, doing the update request, we're passing in our IP address. So this is a chef attribute, which holds the current VM's private IP address. So we're passing our private IP address, and we're saying, close your port 8000, and we're going to tell all the machines. So this is our app server. So we're telling all of our app servers to close port 8000 to me. So we use this when we bring down a load balancer, because the app servers have to have a port open for the load balancer to send requests to it. A load balancer goes down, and if he just goes down without running something like this, well, those ports are still open to its IP address. And on a public cloud, another VM could come up, they recycle IPs, and that new VM, which might not be owned by you, it might be owned by someone else, actually has access to hit your app servers, which is not typically a good thing. So we do this when we're shutting down our load balancer. And what this just says is, hey guys, I'm shutting down all you app servers. Here's my IP address. Get rid of this rule. Shut your port to me. And this is the way we do housekeeping. We only open up the ports that we need. And this is one of my favorite examples, because we're using tags, server queries, and the RightScale platform to perform these types of cluster orchestrations or automations. And again, this doesn't have to be, these VMs don't have to be on the same subnet. They can be in different regions, different clouds. So the power here is the possibilities of what you can do with this are actually pretty great. And I'm pretty excited about these new features. Just some last notable features that came through. Most of these came through on our feedback.rightscale.com site. That's kind of a democratic social voting for features that people would like to see in RightScale. We have multiple block devices. So a block device has the concept of primary and secondary backup and restore, like we talked about earlier. Now you can have more than one of those, multiple attached to per VM. Our load balancer supports multiple vhosts. So our HA proxy template can actually direct traffic to www.yourdomain.com to one set of server arrays, auto-scaling server arrays, and redirect the API vhost to another set of auto-scaling arrays. And we have a few different redirects or rewrites that we support for that. The application servers now can download code from SVN, Git, or remote object store like S3 or Cloud Files. So you can download from multiple sources depending on where you store your code right out of the box. We also support 3 different load balance options out of the box on our app servers. And our application servers are PHP, Tomcat, and Rails. Those are our 3 standard ones. They support ELB, which is Amazon's load balancer, CLB, which is Rackspace's load balancer, and then HA proxy, which is our standard server template. We also support multiple DNS providers, DNS Made Easy, Dyn DNS, Route 53, and Rackspace DNS currently. And we've added an alert for seconds behind master for MySQL database replication, which is great health check for how your replication is doing, if your slave is falling behind or not. And we've also added start-stop support for EBS, just in case you have a dev deployment and you're done for the night. You can just shut that thing down, save some money, start it back up in the morning, and continue where you left off. So that's about it for the deep dive, the features that I wanted to show you guys. We have some references about clouds and picking clouds, and that might be interesting to you. There's also a blog that Partner has actually written, CloudOp has written about using ServerTemplates and Chef together. And for those of you who are more adventurous, Here's our GitHub account, RightScale cookbooks. These are the cookbooks that are being built into our release that's coming out at the end of the month. This is our 12H1 server template release. So if you want to get a jump start, we've done quite a big push on documentation and adding README files so you can get an idea of how these things work, like sysfirewall. All the source code for that is available here. We provide you the source code for all these server templates, everything we do, so you can, like Tim says, use it as a reference design. You can use them out of the box, or you can use them as a starting point for your own creations. So I think that's it.